Okay, here we are. We're going to do section 7.4 right now. Okay, 7.4 has this crazy theorem here. So it says that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle in each other. So I'm going to break apart the one below, but so here's my picture here. Here's my right angle. So it has to be a right triangle. So here's my right triangle. Here's my hypotenuse. So then it says the altitude to the hypotenuse. So remember, your altitude starts at a vertex and it has to be perpendicular to the opposite side. So the altitude to the hypotenuse, because remember, we can call these the altitudes too, but the altitude to the hypotenuse divides the triangle into two triangles that are similar to the original triangle and similar to each other. All right, there's a proof right here. And what I'm going to do here is I'm going to take this triangle right here and I'm going to split it up into the three triangles that it is, okay? So we have a big triangle. So my big triangle, the right angle is at C, the short leg is A, the long leg is B. I have a medium-sized triangle, that's this one right here. In my medium-sized triangle, the right angle is D, short leg is C, the long leg is B. And then I have this small one over here, not drawn to scale. Again, right angle is at D, short leg is A, long leg is CD, okay? All right, so I've got these three triangles. So what I am trying to show you here is that this altitude right here, so the altitude to the hypotenuse, is splitting this big triangle into two other triangles, and all these triangles are similar to each other. So you can see like ACD. ACD is my small triangle. Is it similar to my big triangle? And CBD is my medium triangle. Is it similar to my big triangle? And then those two triangles, so ACD, the small one, is that similar to my medium one? So I'm going to go through all of those right there for you, okay? So I'm going to just do this as two column. So I got my statements, and I have my reasons. So 1, right triangle ABC with right angle ACB and altitude CD. So that's my given. All right, so because I have an altitude, I know then that CD is perpendicular to AB. I mean that by definition, an altitude is supposed to be perpendicular to the other side. So I'm just going to say definition of an altitude. Okay, if I know that I drew these right angles in here, but the only reason why I know that they're right angles is because I know those lines are perpendicular. So if I know that CD is perpendicular to AB, then I know that this is a right angle right here. So angle BDC, so that was from the medium triangle. And then I also know this one over here from the small triangle, and angle CDA are right angles. And again, that's just definition of perpendicular lines, okay? Well, so now I just know if these are all, I already knew that the original one had the right angle there. So now I know that angle ACB is congruent to angle, I should probably line these up. So ACB, CDB, ADC. If it makes you feel better, I'll go back up here and change these letters. But really, just talking about the same angle. And here I can just say all right angles are congruent. So right now, I have all these angles here being congruent, okay? So these are, I'm just going to underline this here so you can see what's happening. Oh, but lo and behold, is not this angle B here the same as this angle B here? So angle B is congruent to angle B. So these two angles are congruent to each other. And voila, angle A is congruent to angle A. So this angle and this angle is congruent to each other, okay? And if they're the same angles, so this is just the reflexive property of congruence. Well, so, okay, let's look at my pictures here. I've got yellow and green, green and pink, green and pink. So I already have two pairs of triangles congruent here. So I know that triangle ACB, let me call it by what they're called up here so we don't get confused. So I know that ABC is similar. So ABC is similar to CBD. And I know pink, green, triangle ABC is similar to triangle ACD. And my reason is just the angle similarity. Okay? So that takes care of, let's see here, it takes care of this one that I was trying to do, and it also shows this one here. So I've got those medium and the small ones congruent to the big one. Well, so let's think here now. I need to show that these two are congruent to each other, but right now the only thing they have is the right angle in common. So let's see here. I know though that the big triangle is similar to the small triangle because I just showed that. So if they're similar, then this angle up here also has to be the same as that angle. So this is also the same, which therefore makes it the same as that angle B, because there's only one angle B in this picture. If I'm looking at the big triangle, there's angle B. If I'm looking at the medium triangle, it's angle B still. I don't need to call it anything else. But, so I can say now that angle B is congruent to angle ACD. So I'm talking about this angle right here. And why do I know that? Because if I have similar triangles, so remember, I already just said this big one is similar to the small one. I said that in step 6. If I have similar triangles, then the angles are congruent. So now, if you look here, I've got the yellow angles, I've already got the green ones as the right one, so now I can just say that triangle ACD is similar to triangle CBD, And again, I'm going to use that AA similarity reason, okay? So, big point here, when you have a right triangle, you draw on that altitude to the hypotenuse, you get 3 triangles that are similar to each other. So like here it says, write the similar statement relating the 3 triangles. So in the diagram, isn't that lovely? That triangle just ended up over there. All right, so I mean, you might want to do like big, medium, small, if it helps you see things. So like the big one, P, the short is, so the short leg is PQ, PR is the long leg, and the medium triangle, S is at the right angle, SP is the short, SR is the long leg, and the small triangle, S again is the right angle, SQ is the short, SP is the long leg. If you write it out like that, then I can just say triangle however you want. So I could do triangle QPR. So QPR is similar to triangle PSR, which is similar to QSP. Okay, so sometimes drawing it out separately is just makes it a little bit easier to see. Okay. Remember before we talked about extremes and means, and we said that like if we had 2 over 3 is equal to 6 over 9, these numbers were the extremes and these were the means. So we're kind of back to that here. All right, geometric mean. So the geometric mean for A and B is the positive number x such that x is equal to the square root of A times B. So you know the arithmetic mean is when you add everything up and divide by the total. So this is just another kind of mean, so it's a geometric mean. But again, if I put, so if these numbers A and B are in the extremes and x is in my means position, what ends up happening here when I cross multiply, I get x squared is equal to AB, so x is equal to the square root of AB. So it's just saying that the means is just the square root of those 2 numbers. So if I wanted to find the geometric mean of 4 and 18, I could set it up like this. So 4 over x is equal to x over 18. I'd cross multiply. X squared is equal to 4 times 18, so 72, and then I'd have to simplify the radical. So 72, so I can take more out of that than that. Nope. So 72 is 36 and 2. So I'd have the square root of 36 times 2, so then it's just 6 square roots of 2. If you don't want to do it that way, again, you can just use that shortcut up there. So x is the square root of 4 times 18. So again, we'd have x is the square root of 72. X is the square root, so 36 times 2 again, so x ends up being 6 square roots of 2. Okay? So you could do it that way if you don't want to set it up like a proportion. Okay. Then we have some fun corollaries. So they're extensions of that theorem. All right. So we're going back to that right triangle, and we have our altitude. So it says the length of the altitude, I'm going to call the altitude x, the altitude of the hypotenuse of a right triangle is the geometric mean of the lengths of the segment pieces of the hypotenuse. So let's say these are my segment pieces. So x, x. So x, so the altitude is the geometric mean of the segment pieces. So if you cross multiply square root, the altitude would just be the square root of the 2 segment pieces. I like to always, I just kind of think about this one as the altitude. So the altitude goes in the mean spot. The altitude is the geometric mean of the two segments of the hypotenuse. So segment 1, segment 2. All right, the next one. Okay. Now I'm going to label the legs, the segments, and then the whole thing is C. If it makes you feel better, let me make it look like the one up above. So A and then B down here. Okay. The altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. So what that's saying here is that, so it says here that each leg is the geometric mean. So the leg is the geometric mean of the hypotenuse and the length of the segment adjacent to that leg. So if I'm talking about L1, I would be B. So L1 would just be the square root of CB. If I was talking about, all right, BC, whatever. L2 is the geometric mean of the length of the hypotenuse and the adjacent segment. So L2 would be the square root of CA. This one I always just think about it as the leg is the geometric mean, so I'm putting it in that spot, mean spot, of the hypotenuse, the whole hypotenuse, and the adjacent segment of the hypotenuse. So in this example right here, it says find x and y. Okay, so x is a leg. So I'm using this second formula here. So I'd have x, the whole hypotenuse is 9, and then the adjacent segment is 4. So x squared is equal to 36, which makes x equal to 6. Y is an altitude. So altitude. So I'm up here in this one if it's an altitude, and I just take the two segments of the hypotenuse. So 4, 5. So y squared is equal to 20. 20 is 4 times 5, so y is, when I take the square root, I'd have 2 square roots of 5. Okay? All right, I'm going to do 3 homework problems with you. So I'm going to do 18 first. 18, actually, let's do 19. 18 is just like the one we just did. That's easy peasy. All right, 19. Okay, 19. So in 19, x is an altitude, y is a leg. So what I'm trying to do, this one, if I want to do the altitude one first, so remember the altitude, so this is 19. The altitude is the geometric mean of the two segments of the hypotenuse. So this segment is 40. This segment right here is 10 because it's 50 minus 40. Cross multiply, x squared is equal to 400. Square root, x is equal to 20. The leg is a leg. I'm sorry, the y is a leg. So I'd have leg. So the leg is the geometric mean of the whole hypotenuse and the segment of the hypotenuse that's adjacent to that leg. So the 10 is adjacent to that leg. So I'd have y squared is equal to 500. 500 is 10 times 5, so I'd have y is equal to, I'm sorry, 500 is 100 times 5, so when I take the square root of 100, I get 10. Can't take the square root of 5, so I have 10 square roots of 5. Okay? All right, I'm going to look at 30. All right, this one says that the altitude to the hypotenuse of a right triangle divides the hypotenuse into segments that have a ratio of length 1 to 2. So the length of the altitude is 8. How long is the hypotenuse? So we know there's the altitude, it's 8. And this is in the length ratio of 1 to 2. So I'm going to label those 1x and 2x. So I don't have any legs here. This is an altitude, so I'm going to use my altitude formula. So altitude. So the altitude is the geometric mean of the two segments of the hypotenuse. Cross multiply. Divide by 2. Take the square root. So 32 is 16 and 2. Square root of 16 is 4, so I have 4 square roots of 2. All right, the problem is the answer says, how long is the hypotenuse? So I would know that the 1x side is just 4 square roots of 2. The 2x side is 2 times 4 square roots of 2, which is 8 square roots of 2. Just pretend like this is a variable. So then the hypotenuse, I would add these up. So again, when you add these up, just pretend it's like 4x plus 8x. So then you'd have 12x. So this is just 12 square roots of 2 for the hypotenuse. Okay? All right, and then the last one I'm going to do with you is 35. Okay, 35. All right, 35 says we have this triangle here, and we're given some measures, and we want to find the other 4. So let's see here. So L1, it tells me, is 2. S2 is 3. So S1, I don't know. I don't know the whole hypotenuse. I don't know the altitude, and I don't know L2. All right, so let's set up some equations here and see what we can solve. So, all right, altitude. So the altitude is the geometric mean of the two segments of the hypotenuse. Okay, well, that's lovely, but I'm going to have 2 variables here, and I can't solve that. So let me come back to that. All right, let me look at this leg. So leg 2. The leg is the geometric mean of the whole hypotenuse and the adjacent segment. Also lovely, but cannot solve that yet because I have 2 variables in there. So how about I start with this 2? So 2 is a leg. So the leg is the geometric mean of the segment, so of the whole hypotenuse, and then the adjacent segment. Well, rats. Still have a little bit of a problem here, right? Because I have 2 variables. But I can rewrite the hypotenuse as S1 plus 3. So now I just have one variable. So I can actually solve this now. So to solve this, I can cross multiply here. So I have S1 squared plus 3S1 is equal to 4. I'm going to move the 4 over here because I have a quadratic. So what two numbers can I multiply to get negative 4? But when I add them together, I get positive 3. So 4 times negative 1 would be negative 4. 4 plus negative 1 would be positive 3. So then I'd have S1 plus 4 equal to 0. So S1 is equal to negative 4, or S1 minus 1 is equal to 0. So S1 is equal to 1. All right. I'm talking about a triangle here. So does it make sense if S1 is negative 4? No. So then S1 has to be 1. Well, then if I know S1 is 1, so S1 is equal to 1, that makes H 4 because H was just S1 plus 3. So here, I can now go back up here and plug in my 4. So L2 squared is 12. So then this would be 2 square roots of 3. And again, over here, we knew S1 ended up being 1. So cross multiply here. A squared is equal to 3, so A is just the square root of 3. Okay? So that is 3 problems from the homework that I just did with you.